somebody asks you how the walls of your house look like, you would say, you know, made of bricks, there is a door, there is a window. But ask astronomers or space physicists how our home in the galaxy look like, and we don't know. So this is what we are discovering now, how the edge of our solar system look like. So one question that you should ask yourself is, what is our home? And we call it the heliosphere. It comes from the sun, heliosphere. It's not really a sphere, it's probably a comet shape, but it's a domain where the wind that comes from the sun, the solar wind, dominates. And once we leave the heliosphere, is what we call the pristine interstellar medium. It's dominated by winds from dead stars, from matter between stars, but it's not our home anymore. It's not a home of the solar wind. So we see that other stars move through the interstellar medium, and they probably also have wings, because you see these beautiful structures that are shocks that you expect to form in front of heliospheres, in this case, astrospheres. So we know they also have homes, also have bubbles. But those pictures, once we look, those are remote sensing. We are using our beautiful telescope to look to how other homes look like from far away. In the case of our solar system, we are able to really go there with the machines that we built and touch and smell how the walls of our home look like. And how we're doing that is with these two spacecraft that were built and launched in '77, when I was 7, and they're still working. Almost 30 years after, they're still working, sending data to us with technologies from before the '70s. So it's an incredible mission. And they are now in this region called the heliosheath, where the solar wind is very slow. It's still within our home, our heliosphere. So in this picture, our heliosphere is all this region, and this is what lies beyond of us, the interstellar medium. So they didn't leave the solar system yet, but they're almost knocking at the door. And, And this picture of the Voyager spacecraft is humongous. If you get a chance to go to a Jet Propulsion Lab, you'll see it's huge and has several of the instruments still working. And if you, like me, grew up with looking at the Voyager pictures in the Life magazines, you saw these beautiful pictures from the outer planets. And Voyager really changed what we know about planets. And now it's changing what we know about our solar system. So what did we learn about the solar system? One thing we learned is, this is a side view of our solar system, that the southern part of the solar system is pushed in. It's not a comet shape, it's distorted. It's almost like somebody gave a punch from outside. And this punch is due to the magnetic field of the galaxy. And this is a picture of if an alien will look from outside, it will see a distorted bubble pushed in the south. What else we learned is that the magnetic field of the sun, here is in red and blue, probably is broken down near the edge of our solar system. It's not anymore field lines that connect back to the sun. And we arrived to this picture that looked like that, filled with little bubbles that fill out all the front of the wall of our solar system to try to explain the data of Voyager. I'm not going to show you the data, but believe me, this data is really weird. And all the typical models that you try to explain can't match all this together. So we put this model together that the magnetic field of the sun, really weird, broke down in pieces, and we are able to explain the data. Now, one of the data that I do want to show you is this recent data that shows that the solar wind particle escaped. They left. In middle of last year, they just left. And this means that we are right at the edge of the solar system. We thought we left. Based on this data, the particle disappeared. We're out. Goodbye. But then we looked at the magnetic field data. The magnetic field data is still typical of solar wind. So we are still inside, but somehow reaching our arm outside and able to touch the interstellar medium. So something's porous, making those particles disappear, but we are still inside. So in the next couple of years, this is what we are going to learn. If the wall of our solar system is porous, as we think, or it's something else. Thank you.
Come on the stage, please. Thank you. So, thank you very much. I've had a message that we, the speakers, need to be up on this podium so that we can be seen. No.
No, it's
just so the cameras can see you.
Okay.
Thank you very much. I want to ask one question. How much is known about how typical or not our solar system is in comparison with those others that you showed pictures of? Are we unusual on the measures that you and your colleagues use, or is our solar system just, plain vanilla, as Dave Kaiser said earlier?
So the sun is a star that is considered for astronomy boring star. It's not very active. So what we're learning about our bubble is probably the less interesting of any other astrospheres. So it's like the vanilla of the vanilla. So probably other astrospheres are much more interesting. So just show us this is so different than we thought. Other astrospheres probably are much more interesting as well.
Okay, thank you. Yes, over here, please.
So, what gives it a magnetic field?
So the sun is it's a dynamo process that happens in the sun. Major problem to explain this process. So there's lots of theories competing. But overall, the rotation of the sun and process within the interior of the sun generate this magnetic field. And we think that other stars, we have measurements, have the same type of magnetic field or more intense.
Okay, thank you. And why is one side of the field pushed in, as you described? Why is it asymmetrical?
The best analogy, imagine you're in a boat going through a river, and there is a different pressure on the river. There is a more pressure in one side, suddenly your boat will be pushed from the south. So the magnetic field doesn't line up with the direction that you're going through the interstellar medium. So you have a higher pressure, and it's sufficiently important that the solar system is distorted.
Okay, thank you. Yes, please, here.
How do you define where the heliosphere ends? Why does it end? Is it just where the last planet orbit ends, or?
No, it's beyond the planet. So the planets end around 40, 50 a year, if you consider Pluto, the funny trajectory of Pluto. But this is way beyond. This is probably 150 a year is the distance from us to the sun. So this is where the solar wind, the pressure of the solar wind, equilibrates the pressure of the interstellar medium. So you have a wall that separates them. The two winds deflect around each other.
Thank you. Another question here, please.
Well, I was kind of wondering why the man in the street should care. If I was sitting in the bar, sipping my beer, why I should worry about this. But then I thought, if you saw other bubbles that look similar to our bubble, would that mean there might be life within that bubble?
Yes, and we are going to hear about life on Mars or other planets, and we're interested in life than any other planets. All this is around stars. All these stars have bubbles. And these bubbles kind of act like a filter of what particles enter towards these extrasolar systems. So it's crucial. You're learning about the house that surrounds any star.
And I didn't quite get, you were talking about Voyager and where it is. I mean, on your measures, I'm right, am I, that Voyager is close to the edge of the heliosphere as you define it, but not yet quite out?
Right. And this was the whole debate last year. We saw this measurement of the particles left, and we thought, okay, we're going to announce we left the solar system. But now we looked at the magnetic field data, it's not. It's the same. So,
all right, thank you. Yes, please.
So my question is on the Voyager 2. Do we expect it to keep working even once it goes beyond the heliosphere? Do we expect some kind of a breakdown?
Yeah, so the energy of the power Voyager goes until 2020. So it will keep going. They will slowly shut some of the instruments, but it will keep going.
Please, you wanted to say something else?
Yeah, I was just about to ask whether going out of the heliosphere might, ruin the Voyager. Is there any possibility of that? Do you know if the mechanisms will break down when it escapes the sun's magnetic field?
Yeah, no. They were really built to endure the strong magnetic field, the strong radiation of the planets, the outer planets. So this is like much a calmer environment for those instruments.
So they're getting less bombarded now than they have been at earlier stages in the journey, I guess. Okay, yes, last question here.
Very quickly, if Voyager is at the narrow end of the heliosphere, how far out is the downstream?
We don't know. Thank you very much.